Hello everyone. Myself Kumod. I am a data science trainer at Brillica Services, and I'll be covering why Python NumPy arrays are pretty much faster compared to Python list, right? In the last video, we covered Python arrays are different things and Python list are different things, right? But they are used to do the same kind of functions. Like we can use them for aggregations, storing values, and different things, right? So what is the difference between list and why do we before NumPy arrays over the list that we'll be covering in today's class, right? So let's start with that introduction. The first thing is that whenever we create a NumPy array or a list, the first thing the Python does is store it in the memory locus, right? Suppose if you have the SSD or SSD or a HDD, whatever you have, right? Whenever you create a NumPy array using np.array in the NumPy library, and by default, if you create a list using the square brackets, it gets stored in your system, right? Then how does that it stored affects the NumPy arrays, and how does that is getting stored that affects the list, right? So that's the only game that we have to understand to know the difference between arrays and list, right? If you understand the difference between the memory location between them, then we can easily address answer like why everyone prefers NumPy array over the list, because of the location and because of the way they store the values. Okay, so for that understanding, we can start with the first point, which is continuous memory. Now, what is a continuous memory, right? Continuous memory basically means, just let me open a notepad so that I can explain you different things. Suppose I have opened this notepad, right? If I go over here and write, suppose continuous memory. Continuous memory means basically suppose you have values, right? Just suppose this is your memory location, right? This is your memory location, and you have a list of values that stores value from 0 to 9, right? Then values get stored like this, right? 1, 0, 2, 3, so on, so on, so on, and the last value will be 9, right? It is a continuous memory. Basically means the whole value is stored in a one line. So that's basically called referred as continuous memory, and this only happens in NumPy. That's not in Python list. So if you want to define what a continuous memory, it's basically a way to store all the values in a single line. Okay, and it is done only by NumPy arrays. NumPy array stores data in a single continuous memory block, allowing faster access and more efficient processing compared to scattered storage. Okay, so let me show you a diagram for that. Let's go through this 1D array, right? Suppose I have created a one-dimensional NumPy array. The values are 0, 1, 2, 3, 4, 5, 6, 7, right? It's stored like this. And when we create the array in this form, in the backend, it is stored like this. It is stored, if I highlight you this, if it is stored like this. It is stored like this in a continuous memory block. In that, the first value is stored as 0, second 1, second, third, fourth, fifth, sixth, and this is the memory view of the data buffer. Okay, in that, each each cell, you can refer this, each cell or each block has the same number of bytes, right? Everyone is having same number of bytes. That's why NumPy arrays are pretty much faster compared to list. The first point, right? Now we just understood that NumPy array stores the data in a continuous memory format, but when we comes to the Python list, how does that stored? Let me show you another diagram. This one, Python list. Python list store the same. Suppose we have value over is 0. Suppose we have value 1, 1, 2, 3, 4, 5, right? Then Python list does not store all the values in the given sequence. It stores randomly and creates a different object for each value, right? Suppose for one, it has stored over here, the second over here, the third over here, the fourth over here, the fifth over here. It does not have a predefined format to store or predefined low level access to basically to store the values, right? So that's why Python lists are very slow compared to NumPy arrays. Okay. The second one, let's move to the second point. Let me clear all the diagrams. Okay, so the scatter list. The second point is scatter list. We just cover like the Python list stores all the values in a form of scatter list, right? It stores different values at a different places. It does not store in a given sequence or a given row or column format. Okay, so that's why scatter list means Python list stores elements in non-continuous memory location, which leads to slower access and poor cache utilization during processing. Okay, so we just understood that Python arrays are basically storing values in continuous memory block, but Python lists are storing values in a scatter list form. So just imagine you have a cupboard, right? And you have different clothes in, and you have to store them. If you stored, suppose you store your search in the first block, in the first section, then in the second upper word, you store your pants. Then you can easily fetch your values clearly, right? But suppose you store your values mix here and there, then you have to look everywhere to get the single cloth you want to search, right? That's why continuous memory are basically much faster and for retrieving data compared to scatter list. So that's the first reason why Python NumPy arrays are pretty much faster compared to Python list. And the difference in the retrieval is almost 50 times more compared to the scatter list. Okay. Now let's move to the third point, which is cache efficiency. Now, what are caches? Caches are basically suppose whenever we create a memory location using codes or something, anything SQL or Python, our system basically creates a cache files for each runs in the execution. Whenever we do that, whenever we have to retrieve the same thing multiple times, it does not go to the exact memory address. It basically reverts to the cache created by your first code when at the time you run it. So if you want to define cache efficiency, it can be defined as continuous memory layout in NumPy improves cache efficiency by leveraging locality of reference, significantly speeding of memory retrieval items. Okay, let me explain this. Suppose let's understand with the basic fundamental. Suppose you write x equal to 5, right, in Python, then it will create a memory address in the backend. Suppose it's created ABC. It's not exactly ABC. I'm just showing you an example ABC, right? And it will create a cache, right? It will create a XYZ, right? XYZ, right? Now, whenever we have to print X, right? Suppose I write print X. Suppose if I write print X, then it will not reflect to the exact memory. It will just go to the cache memory access, right? And it is done only in NumPy arrays. NumPy arrays, right? It is also done in list. It's nothing like it's not done. But suppose when you have all the difference exactly same for different values, then you can fix the same values multiple times. It will not be an issue. But suppose you have if you have different values and each value has a different reference, then the retrieval will be also stored. So that's the third point why Python NumPy arrays are pretty much faster, or we can say Python list are way slower compared to Python NumPy arrays. Okay. The fourth one, which is locality of reference. It's basically the memory address. Whenever we create a view means basically a reference, or we can dedicate that as a normal copy, which creates the same reference of the same element. Suppose we create view basically means suppose if we create an add list with 1, 2, 3, 4, and 5, right? Suppose we do this. Then we create another with just x, right? Then y will be same, right? Y will be 1, 2, 3, 4, and 5, right? It will be same. Now, if I update a value in y, right? Suppose I write y 0, y0 equals to, suppose I wrote 100, right? So the y list will be updated with something like this 100, 100, and so on, like 2, 3, 4, and 5, right? And this thing will also update your x, right? This will also affect your x because we just created a view. We basically created the same reference. So if you do any indexing operation on the y, it will also affect on x, right? It will also become like 100, 2, 3, 4, and 5, right? So it's also affecting your original arrays. That's basically means locality of reference. That's basically means locality of reference. Okay. And locality of reference means suppose if you have the same memory of location, then your locality of reference for each value will be same. But suppose if you are storing the same values at different places, then the locality of reference will be same for each one, but different for different values. So that's why NumPy arrays has an advantage compared to your Python list. Okay. Now let's go to the last point, which is CPU optimization. Now, CPU optimization is a crucial point where NumPy array basically beats the Python list. Let's understand that NumPy is designed to utilize modern CPUs architectures with vectorized operations and low-level optimizations for delivering peak performance. That means whenever we create a, suppose whenever we create a NumPy array of 1D, 2D, 3D or 4D or ND, anything, the CPUs are nowadays CPU has much binary forms, which basically translates the memory location of the NumPy arrays, which is basically not done, and it's done in Python list, and it has different binary values for each values. But when it's come to the vectorization operations of the Python NumPy arrays, then we can easily do that. Just let me show you an example for that. Let's create a two different lists, right? Suppose x equal to 1, 2, right? And y equals to 3 and 4, right? 3 and 4. To create a new list z, and z equals to, and do the sum of each element. Suppose 3 plus 1 equals to 4, then 4 plus 2 equals to 6, right? If you want to get this in the Python list, then we have to use for loop for that, right? For loop for that. But in NumPy arrays, we have vectorization operation advantage. If you write just plus between these two, then it will return 4 and 6. We don't have to write any for loop or any condition. We just have to use the plus operator. So NumPy has many vectorization functions which are basically done using the CPU optimization techniques, and that's why Python NumPy arrays are pretty much simpler and faster compared to Python list. That's also a reason for the comparison. Okay, now let's go to the NumPy arrays and let's understand the different things highlighted over here. In this, we can understand that since it's a 1D array, then the axis will be 0. Axis 0 basically means how many axes does it had. Suppose if you have only one dimensional, then it will axis 0, which is the first axis. Suppose your array is two dimensional, then it will have two axes, axis 0 and axis 1. Okay. If your array is three dimensional, then they do the three axes, axis 0, axis 1 and axis 2. Okay. If you split this in the pointer way, that it will create a memory location in the same 1D array, right? And each will, suppose the data type of this is int 64, in 64 suppose, then it will create a 8 byte memory location for each one, right? And it start from here, and in that there are some pretty much functions which we have to understand. The first one is item size, right? Item size basically tells you the memory location size. Each memory location, what is the size of bytes they are consuming, which will be written 8 byte. Okay. Now shape, the second point is shape. Shape basically means how many rows and how many columns or how many dimensions are present in that. But since it's a 1D array, the shape will be total number of columns or total number of values present in that, which will be 8. Sorry, 8. Okay. Now strides. Strides basically means how many bytes it will be consumed to move from one row to another. So it will be 8. Suppose if you want to move from the second to the third, then it will be 16. Then if you want to move from third one to the fourth one, then it will be 24. Okay. So it's basically creating those values and checking that, and it will be creating that much of values, and then it will directly move to the buffer size. Okay. I hope it's clear about the stripes, shape, and item size. Now let's jump to a quick comparison between Python list and NumPy arrays. The first one point comparison point is data types. Python list can store mixed data types. Suppose when it is a heterogeneous, which means it can store your int values, float values, string values, even boolean values, and complex values, whatever it is required, right? But NumPy is so advanced that it can store only one type of element at a time. You can also create structured arrays using object data type, but if you don't use the object data type, then it will only select or store integer, float, or string, right? and it follows the principle of type promotion. Okay. Now, the second comparison point is dimensions. 1D array by default, higher dimensions require nested list. Basically, suppose if you want to create a 2D list, then we have to use two square brackets. Same with in the array, we can store as many arrays by using the multiple square brackets depending on the requirement and using the np.array function. Okay. Now the third point, memory storage. In Python list, elements stored in a scatter memory location. We just covered that right just now. And in NumPy arrays, it is stored in a one continuous memory block, which is much efficient. Okay. Now let's compare the another feature, which is speed. In Python list, the speed is very pretty much slower due to dynamic typing and scatter memory, right? But in NumPy array, it's up to 50 times faster with vectorized operations and U functions. Vectorized operation, I just gave you an example of the plus between two different arrays, right? And U function basically means the universal functions like maximum, minimum, or string functions, date time functions, whatever you basically whatever functions works in NumPy element wise element, like by going to the first element, then the second, then the third, that's basically referred as U functions. Okay. Now let's jump to the next feature comparison, which is mathematical operations. That basically means it basically requires in Python it basically requires explicit loop or conditional statements. Just now we took an example of two different lists, and if you want to add those elements, then we have to use the for loop, right? But in NumPy we can do that using just vectorized operations. Okay. Now, let's come to the ease of use. Ease of use, I think, though both are basically simple. But when you are aware of NumPy arrays, then you will found NumPy arrays a much very easier compared to Python list, because there are very less built-in function in Python list, but we have many functions already built for NumPy arrays, which does our task, and we don't have to do any large codings or hard codings of loop condition build or logic building. So that's why NumPy array bits when it's come to ease of use as well. Okay, now let's come to the last point of comparison, which is uses in data science, right? Mostly in data analysis, Python are now used, but it is most and commonly used in data science. So let's come to the comparison. Now in Python list, the it's very rarely used for large scale numerical data processing. It means basically, suppose you have loaded your data, right? Then if you load data by using the with command, which is the topic of file handling, then everything you have to do using Python list. But in that you have to build all the logics by on your own using functions, oops concept, or recursions, or your dictionaries or loop, anything. But in NumPy array there are many standard libraries which has the foundation of machine learning, right? Machine learning basically it tells that NumPy, if you know about the NumPy, then you can easily understand Pandas. If you know about NumPy, you can easily understand matplotlib, and even as well machine learning libraries like scikit-learn and deep learning. Okay. So we just covered the use in data science. Let me show you an diagram for that. If you look at this diagram, right, the importance of NumPy in data science. In that, if you look at this, NumPy is the base, right, the root. In NumPy, if you know NumPy, you can use SciPy, which is a library for scientific Python, right? Matplotlib. Then if you know NumPy, you can use it for scikit-learn, machine learning, Pandas, and many more. Similarly, for different domain specific like Python for biology task, for analytic for linguistic like NLP, Singme for geography, quant economics for economics, astronomy for astronomy, everything. But the root cause or the root library for that is NumPy. So NumPy is very crucial in your data science journey. So I hope I have covered the exact difference and helped you to understand what is the exact difference between Python list and Python NumPy arrays, and why everyone in data science uses NumPy arrays compared to your Python list. Okay, so that's all for your this video. We'll cover meeting in the next video. Bye. Have a great day.